What's going on, online learners? Today we are going to need our Home Connections book. So this is different than the book that we used on Monday. Home Connections, it says it on the bottom. When you open this book, it kind of looks exactly like the other one. It has the table of contents. But when you flip to the first page in this one, you can tell it's the Home Connections because there's a little home. Home Connections has a little house with the number 1 on it. So take a look at 10 Ladybugs, page 1 of 2. So that means when it shows page 1 of 2, that means there's going to be 2 pages. This is the first page, and then the second page is on the back. The second page, this page is on the back. Awesome. So let's open up to page 1. I'm going to connect my iPivo, my document camera, and I'm going to share my screen. I hope you guys all slept wonderful. Should be able to see this. All right, my friends, so 10 Ladybugs. 10 Ladybugs. We are going to pull out our number rack again. So our handy dandy little number rack. Remember, it is made up of 20. So 5, 10, 15, 20. If you don't trust me, you can count individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know there's 10 on top. If I push this over, you can see that it's exactly the same amount. So 10 plus 10 is 20. That's using computational fluency. Say computational fluency. You remember that from the video the other day? So computational fluency is counting quickly, being able to say, hey, I know that's 5. I know that I can count 1, 2, 3, 4, 5. Since that's 5, I know that the white ones on the bottom are also 5. 5 plus 5 is 10, plus another 5 is 15, plus another 5 is 20. 15, 16, 17, 18, 19, 20. So computational fluency is all about counting quickly. So if we take a look at our page, it says 10 Ladybugs. 10 Ladybugs. We're going to start on number 1. So you can see number 1, it's in a row. It goes from left to right. I told you we'd be using rows and columns a lot in math. So it says number 1. It's how you know. It's how you know what problem we're on. It says look at the pictures of the gray and white ladybugs below. It looks like they are making a number rack. Fill in the correct number in the empty box to make the equation true. So let's see. I see that the equation says 9 plus something equals 10. Let's count how many ladybugs there are. 1, 2, oh, do you see as my red connects to my white? I know that if I see white, I know that this is going to be a full set of red. This is going to be a full set of 5. Because if there's white next to it, that means 1, 2, 3, 4, 5. Oh, that is 5. And then the white would be counting on from 6, 7, 8, 9, 10. So notice that with the ladybugs. Since there's all of the red ladybugs there, and it goes to the white one, we know that there's 5 red ladybugs. Let's double check though. 1, 2, 3, 4, 5. So on my number rack, I'm going to push over 5 red ladybugs. I'm going to count the white ones. 1, 2, 3, 4. 1, 2, 3, 4. So let's just take a look at that top of the number rack. We know the top of the number rack has 10 beads on it. We know the bottom number rack has 10 beads on it. So if I cover the bottom portion and we're just looking at the top number rack, I know that there are 5 red beads over here. 1, 2, 3, 4, 5. Let's count on 6, 7, 8, 9. 9 plus, look at this bottom bead, plus 1 more is what? It would be 10, it'd be the full 10. So it's kind of funny how on the paper, it actually shows a white or a red ladybug down beneath. So if I were to just look at the number rack like this now, we could say, oh, that's 5, 6, 7, 8, 9. 9 plus one more equals how many? 10, because the number right after 9 is 10. So 9 plus 1 equals 10. Let's take a look at number 2. Let's do the same thing. We know that if there's a red and a white ladybug next to each other, that is a complete set of the red though. Because is there a complete set of 5 of the white ones? 1, 2, 3. Nope. So we know we're going to push over all the red and we're going to add 5 white ones. 3 white ones. 1, 2, 3. 5 plus 3 is what? So rather than being like the sloth off of Zootopia, count with computational fluency. You can say 5, 6, 7, 8. And we are going to add, it looks like 2 more. So 8, 9, 10. Let's look at the problem. 8 plus something equals 10. So we have 8 on top. How many do we have on bottom? 2 more. Do all of these beads over here equal 10? Let's count one more time just to double check. 5, 6, 7, 8, 9, 10. It does. So 8 plus 2 equals 10. All right, let's check out number 3. I know that since the red and the white meet, it looks like all of the red are filled, so I'm going to push over the red. I'm going to push over the red plus 2 more of white, so 5, 6, 7, 7. How many more to 10? If you take a look at that top row, remember the top row equals 10 whole beads. So how many more to 10? 7, 8, 9, 10. 3. Look at the bottom row. It wants us to put 3 red ladybugs on the bottom. So now my number rack matches number 3 picture. You see that? 5, 6, 7, 8, 9, 10. So there are 5, 6, 7, 7 on top. How many on bottom? 3 on bottom, right? There's 3 on bottom. 7 plus what equals 10? 3. So for some reason, I don't know why they're showing the red ladybugs. I kind of like to look at it like this. How many are on the opposite side? 3. Is that the answer? Yeah. So let's actually just keep looking at the top portion. All right, I'm resetting the ladybugs. We see that there's 1 white, so that means there's at least the full set of red plus 1 white. So we see 5, 6. Look at the equation. 6 plus what equals 10? Remember that top portion? This whole top bar equals 10 because 5, 6, 7, 8, 9, 10. There are 10 beads in the top. So if I made my picture look like this picture right here, how many 6 plus what equals 10? How many are pushed over here? 4, yeah. 6 plus 4 equals 10. We're going to do the same thing for number 5. We're only going to look at that top one. Oh, so this one's tricky because if you take a look, are there any white beads for number 5? 1, 2, or white ladybugs? No. 1, 2, 3, 4, 5. There are no white ladybugs. So we have to kind of count just to make sure. Because when we see a white one next to the red one, we know that the red is completely filled. 1, 2, 3, 4, 5. Just like that, there's 5 red ones. So let's look at the equation. It says 5 plus something equals 10. How many are over here? How many haven't we pushed over to make 10? 1, 2, 3, 4, 5. Or looking at it, computational fluency, we know all the reds are over here and all the whites are over here. And we know 5 red beads are on the top row. 5 white beads are on the top row. So 5 plus 5 equals 10. Good job. All right, one more, and then the last 3 you get to do by yourself. All right, take a look at number 6. We're just going to take a look at this top row of ladybugs. 4. We have 4. So on my number rack, I'm going to push over 4. 1, 2, 3, 4. Good job, guys. So let's take a look over here on the right-hand side. If we have 4 ladybugs over here, how many more to 10? Remember, we see now with the white, we see that there's a red right next to it. We know that the white is completely filled up, so it's going to be 5, 6. If you need to, you can count them individually. 1, 2, 3, 4, 5, So 4 plus how many equals 10? 6. Good job, guys. All right, what I want you guys to do is you're going to pause the video and you're going to do 7, 8, 9 by yourself. 7, 8, 9 by yourself. So pause the video. And then this is the portion, I'm going to highlight it. This is the portion that you guys will be completing on your own, okay? You guys are going to complete that on your own. Take a picture and post it in the discussion board for my class, Miss Lane's class, either if she uploads a discussion board or if she wants you to just send a picture or an email, you can upload it like that. So let's move on. I'm going to set this to the side. I'm going to introduce something else. So we saw our number rack, right? We were introduced to the number rack the other day. Now we're going to be introduced to 10 frame dot cards. So this is a 10 frame. This is a 10 frame with the number 1 on it. So if you take a look, we call it a 10 frame because there's 2 rows. There's 5 columns. 1, 2, 3, 4, 5. I'm going to count each square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called a 10 frame because it has 10 frames in it. You can see that on this 10 frame card, there's a number 1. Why is there a number 1? Because there's a red dot right there. So let's take a look at, 10 frames can also come in different colors, red and blue. Let's take a look at this 10 frame. The number is 4. How many dots are there? 4. So if you take a look, it's kind of like our number rack. Like this number rack. Because if I were to clear this, since this is only 10, we're going to actually just work with the red. So don't mind the white portion of it. We're going to look at the red part and we're going to actually look at the 10 frame card. So we know that there's 4. So that means all of these would be pushed off. So 4, how many, if we have 4 dots and 4 beads, how many are there of the red? We know that the bottom hasn't been touched, so it could be 5. 1, 2, 3, 4, 5, 6. 4 plus 6 equals 10. How many dots are missing right here? We know that if we look at a 10 frame, there are 2 rows of 5. So we could be like, oh, that's 5. If you need to, double check. 1, 2, 3, 4, 5. Yep, 5, 6. So there are 6 squares that are not filled in. Let's take a look at another card. Ooh, let's take a look at this one. We know that there are 2 rows of 5 in a 10 frame. The top row is going to have 5. The bottom row is going to have 5. So if we know that the top row is always going to have 5, if we see this, our brain is like, hey, all of those dots are filling up the frames. So we know automatically that's 5. Let's continue to count on using computational fluency. 5, 6, 7. Ooh, that was fast, right? It's faster than counting like this. 1, 2, 3, 4, 5, 6, 7. Our brain is like, oh, that's 5, 6, 7. If you were in a race with someone to count this card the quickest, how would you want to count? Using computational fluency or one at a time? Using computational fluency. All right, friends, what about, I'm going to hide the number. What is that? Oh, this one's different. It doesn't fill up all of the top row. It doesn't fill up all of the bottom row. But take a look. It's the same number as our last card. But look at both of these cards. Yes, they're different colors, but look how they're filled up. They're a little bit different. This one, we have 5 on top and 2 on bottom, and it still equals 7. But this one, we only have how many on top? 4. How many on bottom? 3. 4, 5, 6, 7. So when you're using computational fluency, start with the largest number. We know that 4 is more than 3. So we can say 4, 5, 6, 7. We're counting on. We're counting on. Isn't that kind of crazy though? There are different cards. Ooh, so this is a 10 frame card, correct? How many frames are going to be in this card? 10. So if you look at this card, what do you see? Oh my gosh, it looks like they're almost all filled. So what would the number be? I'm going to reveal it. Oh, 9. That's because you know 10, 1 less than 10 is going to be 9. 5, 6, 7, 8, 9. Good job, guys. Let me continue on. About this one. How many? 10. They're all filled up, and it's a 10 frame, right? It's not a 20 frame. It's not a 15 frame. It is a 10 frame. So if they're all filled up, that's going to be 10. About this one. 3. Good job. Keep going, friends. Ooh, what about this one? We have 3 on top. 1, 2, 3. Plus another 3 more. 1, 2, 3. Is 6 an even or an odd number? It'd be even because look, they all have partners. They're going to go to the store together. They're going to go to a concert together. And they're going to go on a road trip together. They all have partners. Awesome job, guys. So send a picture of your homework assignment, Ladybugs. Finish those 3 problems. Send us a picture or upload it to the discussion board. And then we will be working with our 10 frame cards tomorrow.